How do you custom design a knife handle, program the cam, and mill it out? Let's find out. We'll start by taking a picture of the knife blank that we bought, and we'll bring it into the CAD software. From here, we can calibrate the size of the picture by selecting 2 points and then using the measurement that we took of the knife blank as the input to the measurement here. Now the picture is scaled exactly like it would be in the real world, and we can base further geometry around that picture. The first thing we'll do is make some holes. We know the holes of this knife blank are 3/16 of an inch, so we're going to create the first hole at exactly 3/16 within a sketch, and then we'll copy and paste it, locating it on the areas of the other holes. Next, we'll move into creating the profile of the knife itself. Here we're going to use the spline tool, and we're just going to trace one edge of the knife all the way around. At this point, we have our profile created, and we can turn it into an extrusion. We know that the knife is 1/4 inch thick, and so we're going to set a midplane extrusion to 1/4 inch. We now have the base geometry that can represent our knife, and we can work off of that. We'll create multiple planes, and then we'll create multiple sketches on each of those planes to represent the cross section that we'll use for a loft. We'll select each sketch for the loft, and then create the loft tool. We can see that the geometry is looking pretty good. From here, we'll create a fillet on the front end of the handle. And then we'll tidy up the back end with an extrusion and an additional loft. The final step that we'll want to do is put the holes in. So we'll create an extrude cut using the profile that we created earlier. We now have a real-world, perfect representation of a model that's going to fit exactly on the knife. We can mirror this part and save it separately, and now we have both sides of the knife that we can position in an assembly. We'll use the constraint tools to line everything up, and then we'll position it since we want to cut both of these pieces at the same time. When everything's looking good, we'll export this model as an STL file. Now we jump into CAM. The first thing we do is we load that STL file. Everything's looking good, and we're going to press OK. The next thing that we need to do is set up our stock. Now we have a piece of wood that we've measured and we know the exact dimensions of, so we're going to enter those values into these dimension boxes here. And we want to make sure that the knives are at the bottom of the stock, since that's going to be the flat part. So for that reason, we'll set the Z offset to be 0 on the Z negative. We can see that everything looks to be positioned correctly. The bottom of the handles are at the bottom of the stock, and we want to make sure that we cut just a little bit deeper than the bottom of the stock for our max depth. This will give the edges a really nice finish. The next step is to create our first roughing toolpath. Now we're going to leave everything default, but we're going to use an 1/8 inch end mill, and we're going to change the depth of cut to just be 0.05. The next thing that we'll do is create a toolpath that's going to remove the holes. Now there's lots of different ways that you can do this, but in our case, we're just going to use a pocketing toolpath because it's really quick and easy. We'll select the bottom of each of the holes, and this will create a little preview that we can see for the pocket cutouts. We're going to use the same end mill, and because we're using the same end mill, we don't have to change tools. The last thing that we need to do before actually generating G-code is to set up our supports. If we were just to cut this out, these things would fall out right as the last roughing toolpath went through, and they'd probably hit something or mess up. So we want to make sure they're well supported. We'll just simply click on the model after selecting the support geometry that we want to use, in this case a 0.2 by 0.2 circle, and then we'll press OK. At this point, we're ready to generate G-code. We can see after a few seconds that the toolpaths pop up, and we can kind of check to make sure that they look pretty good. We can also simulate the toolpath to see what the actual geometry is going to look like, make sure no errant things are being cut that we don't intend to be cut, things like that. So everything looks pretty good here, and we're going to go ahead and turn on both of the toolpaths and save our roughing pass. We'll choose the correct output that we want. In our case, it's the carbide inch. and we'll save it as roughing pass. The next thing that we need to do is generate the finishing pass. Now we could leave these toolpaths here, but we're just going to go ahead and clear everything to make a clean slate. Now we're going to modify the distance around the geometry so we're not wasting a bunch of time finishing areas that are around the part that aren't the part itself. Now we're going to create a parallel finishing toolpath. This toolpath is ideal for geometry that kind of looks like this, where the end mill can go back and forth across to achieve a good surface finish. We'll use a tapered end mill, and we'll change the step over to be slightly below the default, just so we have to do a little bit less finishing later on. We'll go ahead and simulate this toolpath. And when we zoom in, we can see the kind of toolpath that is created here. It's going to go back and forth across the part until it looks really nice. We'll do a final simulation just to do a sanity check. And we can see this is looking really good. We're now ready to export this toolpath and go to the machine. Now that we've zeroed our machine, we're ready to start the roughing pass. Now roughing is designed to remove as much material as quickly as possible to expose most of the surface of the part to prepare it for a finishing operation. Finishing operation toolpaths are optimized for surface finish, whereas roughing are optimized for material removal. In this case, we can see that we're drilling deeper and deeper into the object so that we're beginning to finally expose the final part. We're now moving on to the second toolpath of the roughing operation, which is drilling the holes for that pocketing operation that we made earlier. Finally, we move on to the parallel finishing toolpath. You can see here that this toolpath goes back and forth very slowly along the part in very small increments. The surface finish that we achieve with this toolpath is really nice, and it makes really detailed work pretty simple to do and require not that much finishing in further steps. Here we can see the difference between a roughed and a finished part. With a little sanding, finishing, and assembly, our custom knife is done, and it is beautiful. Precise design of parts and assemblies and CNC programming, all in Alibre Workshop.